Good day, students. So we are done now with the conic sections, including the circles, the standard equation of the circle, and the general equation of the circle. This time we will be proceeding now to our third lesson, which is on the definition and equation of a parabola. So at the end of this lesson, you may be able to define a parabola, determine the equation of a parabola, and graph a parabola in rectangular coordinate plane with enthusiasm. So let's go through our parabola. Alright, so as we can see here, we have x values and y values, and we are to graph this in this Cartesian plane. So how are we going to do this one? Note, this graph use 2 units. Okay, so let's start with -4 and 9, -3 and 4, -2 and 1, -1 and 0, then 0, 1, 1, 4, 2, 9, 3, 16, and 4, 25. And if we're going to connect this, we will be forming a parabola that opens upward, right? How to create a parabola? To create a parabola, you just have to consider the focus, the directrix. The focus is the inside the parabola, and the directrix is the opposite of the focus, and we have this midpoint. The midpoint is the vertex of the parabola. Note that the focus to any point on the parabola and to the directrix is equal. What do I mean here? If you're going to draw a line from the focus to any point on the parabola, and from any point of the parabola to the directrix, forming a 90-degree angle, joining the point on the parabola to the directrix, then they are equal distance or equal in length. That's the definition of a parabola. And later we'll be determining the standard equation of a parabola using the vertex form. Okay, so we have here the parts of a parabola. We also discussed last time the parts of the circle. At this time, we'll be going to discuss now the parts of parabola. We have here the vertex, the focus, directrix, the colored blue, the axis of symmetry. It can be vertical or horizontal axis of symmetry, the lattice rectum, and of course our parabola. So these are the parts of our parabola: the vertex, the focus, the directrix, the axis of symmetry, the lattice rectum. Alright, let's go to the definition of the vertex. If we have here a parabola, y is equal to x squared plus bx plus c, where a must greater than 0 or a less than 0, and this will be the nature of our parabola or orientation of our parabola. If a is greater than 0, the parabola will open upward or should open upward, and if a is less than 0, the parabola will open downward. Alright, the vertex definition. If the parabola opens upward, the vertex is the lowest point. So if we have parabola like that, just like this one, if we have the parabola that opens upward, then the vertex is the lowest point. Take note of that. But if the parabola opens downward, just like this one, then the vertex is at the highest point. Next, we have here the directrix. The directrix is this line, color blue. Okay, the directrix is c units below or above the vertex. If we have the vertex is where the highest or the lowest point of the parabola. If we have this vertex and this directrix, the distance from the vertex and the directrix is c units as defined by this definition. The directrix is c units below or above the vertex. The c units there can be any number to represent this letter C, because C is our variable here. The directrix is perpendicular to the axis of symmetry. Alright, so let's say here, this one is our axis of symmetry. And if we are going to draw the directrix, it must be perpendicular with the axis of symmetry. When we say perpendicular, it will intersect the axis of symmetry that will form 90 degrees, both 90 degrees. Okay, the directrix is perpendicular to the axis of symmetry of a parabola and does not touch the parabola. Of course, it is part of the parabola, but it does not touch the parabola because this is the opposite of the focus, right? If the axis of symmetry of the parabola is vertical, the directrix is a horizontal line. It depends upon if we have vertical axis of symmetry, then our parabola is horizontal. But if we have horizontal axis of symmetry, we have vertical directrix, right? Let's proceed with the focus. Okay, the focus is C units above or below the vertex. Above or below depends about the orientation of our parabola. If it opens upward or downward. If it opens upward, it is above the vertex. But if the parabola opens downward, the focus is below the vertex. Okay, the focus of a parabola is a fixed point. So we have this fixed point denoted by letter C. Fixed point on the interior of a parabola used in the formal definition of the curve. Let's proceed with this. Interior of a parabola. Ibig sabihin po niyan, ang focus ay palaging nasa loob ng parabola. Kung naka-opens downward siya, andun pa rin siya sa loob. Pag naka-opens upward siya, andun pa rin sa loob yung ating focus. But the directrix or the line opposite to the focus is always sa labas ng parabola natin. Okay, we have here the axis of symmetry. This line divides the parabola into two parts which are mirror images of each other. So if we have the parabola, this axis of symmetry divides the parabola into two equal parts. It's just like a mirror from of the left, the right, or the upper part or the lower part of the parabola. Review, when we say axis of symmetry, this is perpendicular with the directrix. If our directrix is horizontal, then the axis must be vertical. It depends on, okay? By the way, if your axis of symmetry, if the vertex of our parabola is at the origin, the axis of symmetry can be the y-axis or the x-axis. But if our vertex is at any point on the Cartesian plane, then we have two axes of symmetry. It can be horizontal or vertical axis of symmetry. Okay, this yellow line is our axis of symmetry. Next here, we have the latus rectum. The latus rectum of a conic section is the chord. So when we say chord, it's a line segment that connects the curve, okay? That passes through the focus, all right? So if we're going to draw latus rectum, from this point, it must pass through the focus and to the other endpoint of the parabola. It's perpendicular also to the axis of symmetry and has both endpoints on the curve. Next, by definition, let F be a given point, this one, 0C, and L be a line not containing F. This will be our directrix. So our focus here, our focus has ordered pairs 0C. The set of all points P that its distances from F and from L are the same is called a parabola. So this point P is the point or any point on the parabola. If you're going to connect this to this focus, this one to this line, according to definition, they are equal. Okay, the point F is its focus and the line L is its directrix. Alright, so now, this is what we mean by connecting point P to point F and point P to line L, which forming a 90-degree angles, their distances are equal. And this definition, we will be using this to derive later the standard form of the equation of the parabola. just like what we did in the circle. Okay, so we have here, consider a parabola with focus F0C and directrix L having equation y is equal to -c. If this, from this vertex to the focus, if the distance here is letter C, then from focus to the directrix, the distance would be -c, because the origin is at, the center is at the origin, the distance above it is positive, and the distance below it is negative. The focus and directrix are C units above and below, respectively, the origin. Okay. So we are going to use here the vertex formula. Alright, for other hooks kasi, the focus, they are using letter P to indicate the distance of the focus. But here, this point, they are using letter C. It doesn't matter as long as we got the standard equation of the parabola. So let us again review the distance formula. Right. Okay, so let us now derive the formula of the standard equation of the parabola with the center, or with the vertex at the origin. So we have here a parabola that opens upward, and this focus is at 0C, and this point P is at xy, and this point PL, or the line of the directrix, has an ordered pair of x -c. Why -c? Because since this distance from the vertex to the focus is C, then the distance from this vertex to the directrix must be -c. Because I told you a while back that the above distance above the origin is positive and below it is negative, or the reverse of the focus must be negative here. Alright, so let us use the distance formula. Let's again review what is the distance formula. Our distance formula here is G equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And we have to be very careful which part of this parabola must be substituted with this to get the distance. Okay, so this point, let us name the given points in the parabola. We have point F, we have point P, we have point P sub L, and we have another point P. So point F here is 0C, and point P here is x, y. Point PL here is x -c, and point P is x, y. Alright, so this part, let us denote x sub 2, y sub 2, x sub 1, and y sub 1. By the way, before we forget, this parabola, the vertex at the origin. Okay, so now let us name which is x sub 2 or x sub 1. Okay, so this part, I want this to be x sub 1, this one should be y sub 1. Okay, and also this part should be x sub 2, y sub 2. You might ask me, sir, is it okay to put x sub 2 here in F? It's okay. The answer will not change, but it's my choice to put x sub 1 in F and x sub 2 in P. It's up to you. X sub 1, y sub 1, x sub 2, y sub 2. Alright, so since according to the definition of the parabola, that distance from this point P to this point F is equal from this point P to the directrix line. As you can see, I have put here a grid or a line or a small that are a small line that signifies equality, equal distance between PF and PL, right? Because point or segment PF is equal to segment P sub L. So we will base our standard equation using this by definition. Alright, so let's proceed. So according to distance formula, it's quite so let us use another sheet of paper. Okay, so we will be using this one. So according to the formula, we have segment PF is equal to segment PL. And using the distance formula, that would be distance of PL is equal to the distance of PF, I should say, PL. So this part we will be using now substitution inside. We have here x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. You might get confused. This first distance formula is for PF, and the distance of PPL is this one, right? Let's put them together here. For PF, we have here x sub 2 is x, so that would be x minus 0 squared plus y minus c squared equals, for PL we have here x minus x squared. X here is x sub 2 and another x for x sub 1 plus y minus negative c squared. Then here let us simplify them. Square root of x squared, because x minus 0 is x, so x squared is x squared plus y minus c squared is equal to 0 squared plus y plus c squared. Negative times negative, we will have here positive c. Okay, let's continue here. Now, what we are going to do is to simplify what is inside here. Y minus c squared, y plus c squared, and later we'll be removing the square root. That would be x squared plus, using FOIL method, or if you know the shortcut already, square the first term, y squared, plus twice the product of the first and the second term. Our first term here is y, our second term here is negative c, plus square the last term. And we will continue to another part here. Square the first term, y squared, plus twice the product of the first and the second term, y and c, this one, and square the last term. Alright, so let's simplify. We have here the square root of x squared plus y squared minus 2cy plus c squared also equals the square root of y squared plus 2cy plus c squared. Alright, so this time we'll be removing now the square root sign. How are we going to remove the square root sign? To remove the square root sign, we'll just square both sides. So we will have here so I have used red ink to emphasize you have to square both sides. Alright, so we have already squared them both. Now we have x squared plus y squared minus 2cy plus c squared is equal to y squared plus 2cy plus c squared, because the square symbol has already been removed by the square. Now we have to combine like terms. So just to cut it short, y squared and y squared, since they are in different part of the equal sign, if they have the same symbol, then means we can just cancel them, because if we are going to move one of them, for example, y squared will stay and this one will move. This will become negative y squared. So y squared minus y squared is 0. So if we don't move that, we can just cancel them out to save our time, and cancel c squared. Now we have remaining variables here. X squared minus 2cy is equal to 2cy. What we are going to do is to combine like terms. Negative 2cy and 2cy are like terms. We don't have to cancel them because they have different signs. So we'll just move one variable, this one, to the right to make it positive by applying the addition property of equality. X squared is equal to 2cy. We'll move this positive 2cy, then combine them together. X squared is equal to 4cy. This is now our equation of the standard equation of the parabola with the vertex at the origin. X squared is equal to 4cy. This formula is applied to both opens upward and downward parabola, right? So if letter C here, okay, so let us cut this. If C here is greater than 0 or C is greater than 0, then the parabola will open upward. But on the other hand, if C is less than 0, then the parabola is will open downward. So it depends upon the orientation. We can use this formula both for upward and downward, depends upon the sign of our letter C. If C is positive, then the parabola will open upward, and if C is negative, then the parabola will open downward. So in the part 2 of the video, we'll be solving parabola standard equation and also general form of the parabola.